A rectangular vessel with a base area of 0.04 meters square contains water to a depth of 0.5 meters. Calculate the pressure on the base. 1. Due to the water alone. 2. If a solid block of mass 10 kg is gently placed into the water and rests on the bottom, take gravity to be 10 meters per second squared and density to be 1000 kg per meter squared. Okay, let's solve it. So we have our solution. So the area of the vessel was given to be 0.04 meters squared. So 0.04 meters squared. And the depth of the water, that's the height of the water, which is h, was given to be 0.5 meters. Gravity, which is G, was 10 meters per second squared. And the density of the water, as rho, will be 1000 kilogram per meter squared. Okay, so number one, question one, we have to calculate for the pressure due to the water alone. So number one, but we know pressure, which is P, to be density times gravity times height. So pressure will be equal to density is 1000 times gravity is 10 times the height, which is 0.5. So 0.5. So by using calculator, 1000 times 10 times 0.5, which will give us 5000. So P, which is pressure, is equal to 5000 Pascal. Okay. Question 2. Question 2 says a solid block of mass 10 kg. So a mass which is M, 10 kg, was placed in the water and rests on the bottom on the bottom. So meaning the base of the rectangular vessel is now experiencing two pressure. The first pressure is from the water, which is in the vessel, and the second pressure is the solid block, which is also in the vessel. So we can only calculate the pressure on the base of the vessel unless we calculate the pressure from the block, then that we add it to the pressure of the water on the base. Okay, so let's calculate the pressure from the block. So we know pressure, which is P, is equal to force over area. So we first need to calculate for the force exerted by the block. And we have force, which is F, to be mg. So the force will be equal to mass of the block, which is 10, times the gravity, which is also 10, which will be equal to 100 Newton. Okay, so pressure exerted by the block. So let's make it PB. So pressure exerted by the block is equal to the force, which is 100 Newton, over the area of the vessel, which is 0.04. So 0.04. This will be equal to, let's use our calculator. So 100 divided by 0.04, which will give us 2500 Pascal. So this is the pressure exerted by the block. So to know the overall pressure on the bottom of the vessel, we have to add the pressure exerted by the water and also the pressure exerted by the block. So therefore, total pressure. So total pressure. So P total is equal to pressure by the water plus pressure by the block. Okay. So P total, P total will be equal to 5000 plus 2500. This will be equal to 5000 plus 2500, which is 7500 Pascal. So this is the total pressure exerted by the water and also the block. Thank you very much. Please like, share, leave a comment, subscribe and follow for more. Bye bye.